Okay, we are looking at the first lesson of our Unit 4 unit, dealing with proofs. Bear with me, I don't have my pen that marks, that I write with, so I'll be using my finger, so if it looks kind of off, like I said, bear with me. These first few problems really are just a exercise in logic thinking. We won't see any problems like this, but it's kind of a way to get our brains thinking logically in the flow of the way we do with proofs. What we have, our first thing we're looking at right here is our given. This is our statement. This is where we begin. We want to eventually get to the point where we prove C to be true. So for this practice, we're going to start with Z, and we see it right here. And we would go from Z to M, so we draw an arrow there, which would leave us with M, which would flow to M to A, and from A we would go here, from A to P, and then P to C. So in this manner we've drawn our arrows to connect box to box in a logical way. The second one we're looking at, we have TY, and we're proving Q to be true. So here we have two givens. T is going to go up to D. We're going to have to go back around here to N, N to S, and then S to this box, which is S and K. And from there, we go to Q. Now Y goes to K, then it also goes to this box. So we just connected based on linking letters to the next letter. The next one we had on this page was dealing with B, given B, prove E. So we're going to go from box to box till we get to E. So we're going to start with B, find the other box with the B in it, which takes us to R. From R, find the other box with R, S, to J, to N, to F. Now notice I don't have an F, but I have an empty spot right here, which is my F. To X, X to E, and then E back to the top. Like I said, we're not going to see problems like this on the homework, but we will, it does kind of prepare our minds to think logically. Okay, our notes, we have a few definitions or terms we want to talk about. Postulates, these are statements accepted as true without proof. In mathematics, a proof is a logical argument that uses a sequence of statements to prove a conjecture. Once a conjecture is proven, it is called a theorem. So, postulates are accepted to be true. Now, that doesn't seem to make a whole lot of sense to just accept it without proof, but we'll look at some right here and understand why we don't have a proof for them. Theorems, on the other hand, we can prove them, which is why they are called theorems. So looking at points, lines, and planes postulates. Through any 2 points, there's exactly one line. There's no way to prove this, which is why we don't call it a theorem. It is a postulate because we just accept it to be true. We can't find an instance where it is not true. And a few others, through any 3 points, there is exactly one plane, 3 non-collinear points. A line contains at least 2 points. A plane contains at least 3 non-collinear points. And the last one, if 2 points lie in a plane, then the entire line containing those points lies in that plane. Those are all postulates dealing with points, lines, and planes. Intersections of lines and planes. If 2 lines intersect, then their intersection is exactly 1 point. If 2 planes intersect, then their intersection is a line. Okay? So just some examples of some postulates that we're working with. one point I would like to bring out is this symbol right here. It means that it's congruent as opposed to being equal. If it's congruent, we're talking about the shape of it. For instance, angle A is congruent to angle B. That means we don't know what the measures are, but we know that the two angles have the same shape. If two triangles have the same shape, they're congruent. Now, if we're talking about angle measure, or the measure of a segment, we are talking about equal. For instance, you might have noticed that when we said the measure of angle C plus the measure of angle B equals 180. That means we use equal, not congruent, because we're saying that the measures of those two angles is equal to 180. Again, talking about number measure. Properties of equality. These are all things we know to be true. If I have A and B and I add a number to both sides, then it's still true. For instance, if I have x minus 3 equals 8, well, we solve x for x by adding 3 to both sides. Well, we can do that because of this addition property of equality. It leaves us with x equals 11 because we've added the same sum to both sides. In this case, we did it with 3. We can do that with subtraction. That's the subtraction property of equality. We can multiply them, multiplication property of equality, and we can even divide them by the same number to keep both sides equal. Some more properties of equalities. Reflexive property just states that anything is equal to itself. Symmetric property doesn't matter the order that we put them in, they're still equal to each other. Transitive property, if A equals B and B equals C, well then A is equal to C, right there. Substitution, if A equals B, then B can be substituted for A in any expression, which means from there forward we can put B in place of A, replace it with the substitution property of equality. We also have distributive property, which says that if I have this right here, I can distribute that A to multiply it times the B and the C to get AB plus AC. Okay, let's look at this next question that we have. Given the equation 3 equals x minus 2, you quickly write that the solution is x equals 5, which is true. We all can probably do that in our heads. Which property, though, allows us to do that? Well, if we have 3 equals x minus 2, we're adding 2 to both sides, which allows us to get 5 equals x. So the answer to the question, what property, we're using the addition property of equality. Now, if we wrote it over again as x equals 5, then we could even go so far as to say that that is the symmetric property, which allows us to flip the two sides. Okay, now let's look at our first proof that we're going to look at right here. Algebraic proof means we're going to be solving algebra problems and proving those statements. With some of these properties. The first thing, always going to start with what they gave us. 2, 5 minus 3a minus 4a plus 7 equals 92. The reason for that, the first reason will always be given. Okay? Now, this doesn't say it, but we are trying to prove that a equals negative 11. So if we were solving this problem, what would the first thing be that we would do? Well, we would distribute that. We would distribute the 2. So 2 times 5 equals 10. 2 times negative 3a equals negative 6a. Negative 4 times a is negative 4a. And negative 4 times 7 is negative 28, and that would be equal to 92. Now, what property allows us to make this change? That would be the distributive property. And I'll just cut it short right there. What would we do next if we were solving this? Well, we would combine like terms. We would say negative 6a and negative 4a is negative 10a. 10 minus 28 is negative 18, and that would be equal to 92. Well, what allows us to do that? We didn't really say this, but sometimes we can just write simplify, because we're simplifying that equation. Now we would add 18 to both sides so that I get my a by itself, and negative 10a would equal 92 plus 18. We would have 110. What allows me to do that? Well, I added 18 to both sides, so we would be having the addition property of equality. Next, I would divide by negative 10, which would leave me with negative 11. A equals negative 11. That's what I'm trying to prove. How could I do that? Well, that was the division property of equality. Okay? And that was our first proof that we looked at. Now, a couple other postulates that we want to talk about before we continue. Segment addition postulate just says that when if I have a segment AC, well, it's equal to the two segments AB plus BC. This segment plus this segment equals the whole segment. Okay, we already knew that, but the name for that is segment addition postulate. Angle addition postulate is the same thing. If I have angle ABC, well, it's equal to the sum of AD plus DBC, the two smaller angles that are within it. All right. This right here, we're given segment, they're collinear. AC is equal to BD. That's this segment is equal to BD. They want us to prove that AB is equal to CD. The first here is the first statement. Remember, that's the goes in our statement section column of our proof. So AC equals BD, that's given, which is the reason. Now look what they did here. They said that AC is equal to AB plus BC. Well, again, that goes right along with our segment addition postulate. Remember what that says? We just looked at that on the previous page of the notes, that if I have a whole segment, AC, it's equal to the two segments that are within there. And that's the same for AC and BD. Now you look at number 3, they use the substitution property of equality. What could we substitute? Well, AC, remember, if AC is equal to AB plus BC, then anywhere we see AC, we can replace that. So we're going to take AC equals BD, and we're going to replace AC with this right here. So we're going to have AB plus BC equals, and instead of writing BD, we're going to replace that with BC plus CD. Okay, so we've substituted those two values for AC and BD. Now look what they end up with. They end up with AB equals CD. If we were to subtract BC from both sides, we would be left with AB equals CD. So we're going to use the subtraction property of equality. And looking at the last section of the notes, So this next one, midpoint theorem. If M is the midpoint of AB, then what we have is we've got a segment AB with M as my midpoint. That means these two segments are congruent. So AM is congruent to MB. That's what the midpoint theorem says. And the last question, we're going to use the midpoint theorem because if X is in the midpoint of WY, so we've got this segment, X is the midpoint, that means these two segments are congruent, and Y is the midpoint of XZ, there's XZ, Y is the midpoint, so these two segments are all three segments are congruent. How can we explain that? Well, first what we're going to say is segment WX is congruent to segment XY. Why? Because of the midpoint theorem. And we're also going to say that XY is congruent to YZ because of the same thing, midpoint theorem. Now what we have is WX equals XY, or congruent to XY. XY is congruent to YZ, so that means these two are congruent to each other. And the reason they're congruent is the transitive property. If you need to look back at the chart, look at that. Remember, that's A equals B, B equals C, therefore A equals C. Now, another thing we could have said, we could have gone ahead and said that the same thing could be proven with substitution. So we could have used two reasons for the same thing, because if XY equals YZ, we could have substituted XY here with YZ and had the same statement. Okay, your homework. Okay, right here on your homework assignment, you are going to do exactly what we did. For instance, you're going to distribute 1/5. So you're going to have 1/5 A plus 10 times 1/5 is 2 equals -3. And the reason for that is distributive property. And you're going to continue until you come down to A equals something and you have a reason for that. 2 is exactly the same. 3 is tricky because what you're going to need to do first is the perimeter is 9.5, so you're going to replace the P with 9.5, and then 1 1/4 is the width, so you're going to replace the W with that. So you're going to start with the equation 9.5 equals 2 times the length plus width, which was 1 1/4, which is 1.25. So that's kind of your first statement, which is given, and then you'll solve the rest of it just like we did on 1 and 2. Number 4, they've given you the statements. You have to come up with the reasons. Again, we're going to start with given. Now, you could have also started on this one with segment addition postulate, but we'll start with given. They substituted the numbers for the segment letters, and from there you solve it just like we did the previous one. 1 through 8, you're going to have to look at your chart to see which property fits those. Remember, which property of equality fits those instances. Okay, and the last one, I'll go ahead and give you the equation. You normally would have to fill this in on your own, but I'll give it to you. And that's the given. For number 2, I'll give you that one as well. That's an S right there, not a 5. Okay, and that again is given. And the last two problems you can do without any help, so hopefully these no help.